Far beyond the planets, beyond the last faint traces of the sun's protective reach, an ancient traveler is still whispering to Earth. It should not be possible. Built in the 1970s, long before modern computers, long before the internet, and even before many of the scientists studying its signals were born, Voyager 1 was never expected to survive this long. It had been created for a straightforward mission: fly past Jupiter and Saturn, capture photographs, collect scientific measurements, and eventually fade into silence once its work was complete. But silence never came. Instead, Voyager 1 kept moving. It slipped beyond the familiar planets, crossed the edge of the solar system, and entered the vast darkness between the stars. From a place no human-made object had ever reached before, it began sending home a message that challenged everything scientists thought they knew. Before we uncover what Voyager 1 discovered beyond the edge of our solar system, take a moment to subscribe to the channel. Your support helps us continue bringing you fascinating stories about the greatest mysteries of space. And we're working toward our goal of reaching 1,000 subscribers. Now, let's continue the journey. The region beyond our solar system was expected to be quiet, smooth, and almost empty. A cold, black ocean stretching endlessly through space. Yet Voyager 1 found something entirely different. It detected a faint hum. It found turbulence where calm had been expected. It revealed a violent boundary surrounding our solar system like an invisible shield. The most remarkable part of the discovery was not simply that deep space was different from the predictions. It was that the mystery reached all the way back to Earth. The very boundary Voyager 1 crossed is the same barrier that helps shield our planet from the powerful radiation constantly flowing through the Milky Way. By looking back across that distant frontier, the spacecraft uncovered something scientists still cannot fully explain, something that may reshape our understanding of how life survives inside the sun's enormous protective bubble. The story had begun decades earlier. On September 5, 1977, Voyager 1 rose from Earth with a mission that seemed both bold and achievable. It would travel to Jupiter and Saturn, photograph their worlds, gather valuable scientific data, and complete one of the greatest planetary flybys ever attempted. After that, the mission was expected to end. For a while, everything unfolded exactly as planned. In 1979, Voyager 1 swept past Jupiter, returning breathtaking close-up images and measurements that transformed humanity's understanding of the giant planet. A year later, in 1980, it reached Saturn, revealing extraordinary details about its magnificent rings, mysterious moons, and powerful magnetic environment. Then the planets gave Voyager 1 one final gift. Their immense gravity acted like a series of giant slingshots, hurling the spacecraft farther and faster into the darkness than any human-made object had ever traveled. By the end of the 1980s, Voyager 1 had become the most distant spacecraft ever built. Yet it refused to fall silent. It continued measuring. It continued transmitting. Across an ever-growing ocean of space, its faint radio signal continued its long journey back to Earth. Then came the moment no human machine had ever experienced before. In 2012, Voyager 1 crossed the heliopause, the true outer boundary of the sun's influence. This was far more than a distant region beyond the planets. It was the frontier where the solar wind finally lost its strength, and the pressure of interstellar space pushed inward from the opposite side. Everything within that vast bubble belonged to the sun. The planets, their moons, countless asteroids and comets, Earth itself, and every living thing that had ever existed. Beyond that invisible boundary, however, lay a completely different realm. The space between the stars, filled with the ancient plasma of the galaxy, and shaped not by our sun, but by the immense forces of the Milky Way. When Voyager 1 crossed that frontier, it became the first human-made object ever to enter interstellar space. More importantly, it kept talking. For the first time in history, humanity had a working scientific instrument operating on the far side of the solar system's invisible wall. What it discovered there was not what anyone had expected. For decades, scientists had carefully modeled what interstellar space should be like. They never believed it would be completely empty, because space itself is never truly empty. Even so, they expected the plasma between the stars to be thin, cold, and relatively smooth, forming a quiet background beyond the sun's protective bubble. Then Voyager 1 entered that distant realm, and the silence disappeared. Everything that had ever known the warmth of the sun existed inside that enormous invisible bubble. The planets circled within it. Their moons drifted through it. Asteroids and comets wandered across it. Earth, with every ocean, forest, city, and every living creature that had ever existed, belonged to it as well. But beyond that invisible frontier lay a completely different realm. There, between the stars, stretched the ancient plasma of the galaxy, a region shaped not by the sun, but by the vast forces of the Milky Way itself. The moment Voyager 1 crossed that unseen boundary, history changed forever. It became the first human-made object to enter interstellar space. Even more remarkable, it continued sending signals home. For the first time, humanity possessed something it had never had before, a living scientific instrument operating beyond the solar system's invisible wall. What it began reporting was nothing like scientists had expected. For decades, researchers had carefully constructed models describing what interstellar space should be. No one believed it would be completely empty, because space is never truly empty. Even so, they imagined the plasma between the stars would be thin, cold, and relatively smooth, forming a quiet backdrop beyond the sun's protective bubble. The moment Voyager 1 entered that region, the silence vanished. Beginning in 2017, its plasma wave instrument detected something astonishing. A persistent, narrow-band emission appeared within the interstellar plasma, a faint, continuous hum. It was not a brief burst. It was not the aftermath of a passing shockwave. It was not an isolated reading that could simply be dismissed as electronic noise. The signal endured year after year as Voyager 1 traveled deeper into the vast space between the stars. That persistence transformed the discovery into something extraordinary. The mysterious hum gave scientists an entirely new way to measure the density of interstellar plasma continuously. Before Voyager revealed it, researchers had been limited to scattered snapshots, usually captured only when powerful solar eruptions sent disturbances racing toward the outer boundary, causing the surrounding plasma to respond. Those rare opportunities provided useful information, but they were far from complete. It was like trying to understand the climate of an entire planet after witnessing only a single storm every few years. Voyager 1 changed everything. Instead of isolated glimpses, the persistent emission became a constant stream of information, a real-time record of the interstellar medium surrounding the spacecraft. As scientists followed that record, an unexpected picture slowly emerged. Interstellar space was anything but featureless. It possessed structure. Its density changed from place to place. Turbulence rippled through it. Motion and complexity existed on scales that earlier models had never fully captured. The region beyond the solar system was not a silent waiting room separating one star from another. It was active. It possessed texture. In many ways, it behaved like a form of cosmic weather. And Voyager 1 was not observing that weather from a safe distance. It was traveling through it, becoming the only spacecraft ever to measure those conditions directly. Yet the discovery opened another mystery. Scientists still do not know exactly what creates the strange hum. Some researchers believe it may come from thermally excited plasma oscillations, natural vibrations moving through the interstellar plasma itself. Others suggest it could be the result of quasi-thermal noise, a different physical process capable of revealing the density and temperature of interstellar space in ways that could require scientists to revise long-standing models of the interstellar medium. Whatever the final explanation proves to be, the conclusion remains impossible to ignore. The space beyond our solar system is far more complicated than humanity once believed, and Voyager 1 is detecting phenomena that scientists are still struggling to understand. The mysterious hum, however, was only the beginning. Before Voyager 1 fully entered interstellar space, it had already passed through one of the most important frontiers in the solar system, the heliopause, where the outward flow of the sun's solar wind collides with the pressure of the surrounding galaxy. Scientists always expected this boundary to be unusual. Most models predicted a gradual transition, where solar particles would slowly thin out, while particles from interstellar space gradually became more dominant. The change, they believed, would resemble a smooth blending between the sun's environment and the galaxy beyond. Voyager 1 discovered something very different. What Voyager 1 found at the heliopause was nothing like the gentle transition scientists had imagined. At the very edge of the solar system, particles were racing through space at extraordinary speeds. Charged particles slammed into one another, compressed together, and generated temperatures reaching tens of thousands of degrees. This was not happening inside the sun. It was not taking place within a distant star. It was unfolding at the outermost boundary of our own solar system. The discovery was so dramatic that some researchers began describing the region as a wall of fire. It was not fire in the ordinary sense. There were no flames burning in the darkness, no oxygen feeding a blaze, and no glowing surface stretching across space. Yet the energy was unmistakably real. Around the sun's enormous protective bubble existed a dense, violent concentration of charged particles, creating a hot and turbulent frontier unlike anything scientists had expected. That frontier was far more than a distant cosmic landmark. It was part of Earth's protection. The heliosphere acts as a giant shield, helping deflect dangerous, high-energy cosmic radiation streaming through the galaxy. Much of that radiation is born in violent cosmic events, including the explosions of dying stars before traveling across interstellar space. If the heliopause is more turbulent, more energetic, and more deeply connected to the surrounding interstellar environment than earlier models suggested, then the shield protecting the inner solar system is also far more complicated than anyone realized. Suddenly, the discoveries being made billions of kilometers away were no longer only about deep space. They reached all the way back to Earth. As Voyager 1 continued exploring the boundary, another surprise emerged. Scientists had expected the sun's magnetic field and the magnetic field of the Milky Way to remain largely separate, divided by the edge of the heliosphere. Instead, Voyager detected evidence that these enormous magnetic environments were interacting with one another, exchanging energy through processes that scientists were only beginning to understand. The discovery revealed something profound. The solar system and the galaxy are not isolated worlds existing independently of one another. They are connected. At the frontier between our home and interstellar space, magnetic fields continuously rearrange themselves. Charged particles accelerate. Energy flows back and forth between the sun's protective bubble and the wider galaxy. That realization was not a minor adjustment to existing theories. It fundamentally changed humanity's picture of its place within the Milky Way. Earth is not resting safely inside a sealed, isolated dome. Instead, our planet travels within a living magnetic bubble that constantly presses against an active and dynamic interstellar environment. And on the far side of that invisible frontier, only one witness has ever watched those events unfold directly. That witness is Voyager 1. Yet perhaps the most dramatic chapter of its story was not what it discovered. It was how close humanity came to losing the only machine capable of making those discoveries. In 2023, Voyager 1 suddenly began transmitting corrupted data. The spacecraft itself was still functioning. Its radio signal continued crossing the immense distance back to Earth. But the information carried inside that signal had become unreadable, reduced to scrambled code sent from the most distant machine humanity had ever built. For 5 long months, engineers faced an extraordinary challenge. Voyager 1 was more than 24 billion kilometers from Earth. No astronaut could reach it. No repair mission could be launched. Every command transmitted from Earth required nearly an entire day to arrive, and every reply demanded almost another full day to return. Even the smallest troubleshooting attempt became painfully slow. A single question meant waiting 2 days for an answer. One adjustment required another 2 days before anyone could know whether it had worked. Every decision demanded patience, precision, and hope. Eventually, the mystery was solved. The problem came from a single degraded memory chip inside Voyager 1's flight data system. After decades of exposure to cosmic radiation, one tiny piece of hardware had corrupted the software responsible for organizing the spacecraft's scientific information. That tiny failure nearly silenced humanity's only working instrument in interstellar space. Refusing to surrender, the engineering team devised an extraordinary solution. They divided the damaged software into smaller sections, relocated those sections into healthy areas of memory, and rebuilt the spacecraft's operating logic across billions of kilometers of empty space. It was the closest thing humanity had ever attempted to brain surgery on a machine built in the 1970s, performed remotely with a 2-day delay after every movement. Against the odds, it succeeded. Voyager 1 began speaking clearly once again. Against every expectation, Voyager 1 found its voice again. Readable scientific data once more began flowing across the unimaginable distance between the spacecraft and Earth. The mysterious hum returned. With every transmission, the invisible map of interstellar plasma continued to unfold, revealing details of a region no human instrument had ever explored before. For a moment, it felt like an impossible victory. But everyone involved understood a difficult truth. The victory could never be permanent. Voyager 1 was growing old. Its radioisotope power source, the heart that had sustained it for decades, was slowly losing strength year after year. To keep the mission alive, engineers had already shut down some of its scientific instruments. More would inevitably follow. Every remaining watt had become precious, forcing impossible choices about which systems deserved a little more time and which would be allowed to fall silent forever. Even as its strength faded, Voyager 1 continued setting new milestones. In the years ahead, it would reach another symbolic distance. It would become one full light day from Earth, so distant that even a signal traveling at the speed of light would require 24 hours to reach it. A command transmitted from Earth on one day could not receive a reply until 2 days later. No human-made object had ever traveled that far while still alive and communicating. Yet distance was no longer the greatest challenge. Time was. Unless another engineering miracle extended its life, Voyager 1 was expected to fall silent sometime during the early 2030s. When that day arrives, the spacecraft itself will not stop. It will continue its endless journey through the Milky Way for millions, perhaps even billions of years. It will still carry the golden record, preserving Earth's greetings, music, natural sounds, human voices, and the symbols of a civilization that once reached for the stars. But something precious will be lost. The science will end. The living conversation between Earth and interstellar space will come to an end. The mysterious hum will continue vibrating through the plasma between the stars, but humanity may no longer have anything there capable of hearing it. That is where the true urgency lies. Voyager 1 transformed the edge of the solar system from an abstract boundary on scientific diagrams into a place filled with unanswered questions. It revealed an interstellar environment filled with turbulence, a boundary charged with heat and magnetic energy, and a protective shield surrounding our solar system that proved far more complicated than anyone had imagined. Yet the only machine capable of continuing those measurements is slowly running out of time. Even now, the greatest discovery may still be unfolding. The story may not be finished, but the only witness telling it could fall silent before the final chapter is written. So what did Voyager 1 truly discover when it crossed the edge of our solar system? It revealed that the boundary separating our world from the rest of the galaxy is not silent. It is not smooth. It is not a simple line where the influence of the sun quietly fades into interstellar space. Instead, it is alive. It is a restless frontier filled with plasma, magnetic fields, charged particles, and flowing energy. A place where the solar system does not gently come to an end, but constantly struggles against the immense pressure of the galaxy beyond. Perhaps that is the greatest lesson Voyager 1 has ever sent home. For generations, humanity pictured the edge of the solar system as a distant, frozen border where the solar wind gradually weakened and the interstellar medium slowly took its place. Voyager 1 replaced that simple picture with something far more extraordinary. Hidden within the darkness, it found a persistent, narrow-band hum traveling through interstellar plasma, continuing year after year across astonishing distances. That faint signal revealed that the space between the stars is neither empty, nor uniform, nor silent. It possesses density. It contains structure. It is filled with turbulence. It behaves almost like weather in a region that humanity had never before been able to enter.